Hello, welcome again. We are solving Mechanical Engineering Paper 2 of year 2025 of Indian Forest Services Mains. Question number 8B is in an auditorium which is to be maintained at a temperature not exceeding 24 degrees Celsius and a relative humidity not exceeding 50%, a sensible heat load of 132 kilowatt and 84 kilogram per hour of moisture has to be removed. Air is supplied to the auditorium at 15 degrees Celsius. Calculate 1. How many kilogram of air per hour must be supplied? 2. What is the dew point temperature of supply air and what is its relative humidity? 3. How much latent heat is picked up in the auditorium? 4. What is the sensible heat factor? 5. What is the ADP of coil and its dpf? The cyclometric chart is attached. So here the temperature of the room to be maintained is 24 degrees Celsius, suppose it is here, and supply air temperature is 15 degrees Celsius, and sensible heat to be removed is 132 kilojoules per second. Okay, suppose Ma is the mass of the air supplied, then the heat picked by air supplied is your Ma Cp Ti minus Ta. Okay, Ti is your room inside room temperature. Okay, and Ta is your initial air temperature. So this is equal to 132 because the sensible heat to be removed is 132. So Ma will come out as 14.59 kilogram per second, or if you multiply it by 3600, then it will be 52537.31 kilogram per hour. So that quantity of air has to be supplied per hour. Okay. Now we have to remove some moisture also. So mass of the moisture removed per hour is 84 kilogram per hour, and moisture carries latent heat. So latent heat in kilojoule per kilogram is your 2500. So the latent heat to be removed is your 84 into 25. So that is your 210,000 kilojoule per hour. Or if you divide by 3600, then it will be 58.33 kilowatt. Okay, so that is the latent heat to be removed, and this is the sensible heat to be removed. So total heat to be removed is the summation of these two. So it will be 190.33 kilojoule per second or kilowatt. At initial conditions or at inlet conditions of room, that is 24 degrees Celsius and 50% humidity. If we see the cyclometric chart, then 24 degrees Celsius and this is 50% relative humidity. The enthalpy is your 47.5. So here the enthalpy is your approximately 47.5. Okay, and the total heat that is to be removed is your 190.33, and it will be removed by the air supplied. So final enthalpy of the air will be a 47.5, and initially the air is supplied at an enthalpy of 4 HA. So we can determine this HA because we have Ma, we have HI, we have this total heat to be removed. So HA comes out as 34.45 kilojoules per kilogram. Okay. So now initial air temperature is 15 degrees Celsius. So we can now locate this air supplied point. So that is your 15 degrees Celsius, and this enthalpy is approximately 34.435. So this will be the point. Okay, so this will be the point. So here You can see that relative humidity is approximately 80% and room dew point temperature is approximately 12 degrees Celsius. Okay, so this is the room sorry, air supplied dew point temperature, that is your 12 degrees Celsius, and relative humidity is 80%. Okay, so now if we join this inside condition and air supplied condition and extend it to this 100% relative humidity, then it will give apparatus dew point. So this is given by, this is your point of 24 degrees Celsius and relative humidity 50%, and this is the point. So if we join this and extend it up to this 100% relative humidity, then the temperature will be at 10 degrees. So this will be your apparatus dew point temperature. Okay, so now we have apparatus dew point temperature. So we can determine bypass factor also. This temperature is 15 and this is your 10. So this is the air that is bypassing. 15 minus 10 divided by 24 minus 10. This is 24, this is 10. 24 minus 10, so that will be at 0.35. Okay. And sensible heat factor is your sensible heat to be removed divided by total heat to be removed. This is 0.693.